In this video, I'm going to discuss about this basic character of these arylamines. In the part 1, I've discussed about the basic character of these amines with reference to ammonia. Let's see how this can be explained. Right. If you take aniline, yes, what is aniline? This is aniline, right? This is aniline and this is ammonia. Let's compare the basicity of these two. That means how it can donate the lone pair of electrons and how easily each one of these is going to donate the lone pair of electrons which are present on the nitrogen. Right. In my first video, I discussed about why aliphatic amines are more basic than ammonia. Now, let's look at this arylamines, that is aniline, for example. Yes, if you look at the pKb values, pKb is nothing but the measure of the basicity, which is inversely proportional to the basicity, right? The less the pKb, the more basic the compound is. So for example, ammonia, which is 4.75 pKb, aniline, it is 9.13, which means that the less the pKb value, the more basic character the compound has. So the ammonia is having 4.75 and aniline is having 9.13, which means that ammonia is more basic than aniline. And how can this be explained and why? What's the reason for this? Yeah, if you look at this, see here NH2 is attached to an aryl group, right? There's a benzene ring. There is no such substitution which can be seen in the ammonia. There are only hydrogens here, right? If you look at one more thing is that the basicity is related to the ease with which the lone pair of the electrons on the nitrogen can be donated. So whichever is going to donate the electron pair on the nitrogen easily, that compound will be more basic. So it's related to what? It is related to the availability of the electrons on the nitrogen. The more easily it donates, the more basic it is, right? But if you look at this lone pair of electrons on nitrogen, yes, it is in conjugation with the ring. It is in conjugation with the ring. That means it is donated. I mean, the lone pair of electrons on the nitrogen are donated into the ring. And let's look at these resonance structures. And from the pKb values, it's clear that ammonia is more basic than aniline. And let's see how this can be explained. Yes, if you look at these resonance structures, these are the resonance structures which are possible for aniline, where the lone pair of electrons on the nitrogen are in conjugation with the pi electron cloud of the benzene, pi electron system of the benzene. And as a result, what is happening here, and this is ammonia, the lone pair of electrons which are present on the nitrogen is less available for them to donate now, making them less basic. Right? This is the reason. What is the reason? The lone pair of electrons which are present on the nitrogen is donated, is in resonance with the pi electron cloud of the benzene ring, which makes the lone pair of electrons on the nitrogen less available for the donation. That means which are making it less basic, right? So they're in conjugation with the benzene ring and thus making it less available for protonation. And this is the reason why anilines or aromatic amines are less basic than nitrogen, because the lone pair of electrons which are present on the nitrogen or in conjugation with the ring, making them less available for the nitrogen, because basicity is nothing but what? The ease with which they donate the electrons. If they easily donate the electrons, that one is more basic, because here the lone pair on nitrogen is in conjugation. It cannot donate the lone pairs on nitrogen easily, so making ammonia more basic than aniline here, right? So when we look at the resonance structures again, comparing with the anilinium ion, right? Now this one, because of the presence of lone pair of electrons on the nitrogen, it can donate this lone pair to the acid, that means H plus, so resulting in the formation of anilinium ion. This is the anilinium ion, right? So when we look at the stability of both aniline and anilinium ion, which can be explained based on the resonance structures again. So this is the second way of explaining why aniline cannot the lone pair of electrons nitrogen when compared to that of this ammonia. Right. Here these are the resonance structures of aniline where 5 resonating structures are possible. But when we look at the anilinium ion, there is only 2 structures which are possible. This is the anilinium ion, which is formed by the donation of electrons on the nitrogen to the proton, resulting in the formation of anilinium ion. There are only 2 resonance structures, and these are the Kekulé structures, if you can recollect them, right? These are the Kekulé structures, and we know that the compound with more number of resonating structures is more stable when compared to that of the compound with less number of resonating structures. Here only 2 structures are possible. Here 5 structures are possible. For definitely aniline is more stable than anilinium ion, right? So if this is more stable, then why will it donate the electrons to the proton, making itself anilinium ion? So this is the second reason, second way of explaining why aniline is less basic than ammonia. Right. Then when we look at the basicity of the substituted anilines, for example, if I'm taking this is the aniline, and if the presence of electron, this is aniline, electron releasing groups. What are the electron releasing groups? Like OCH3 and CH3 here. This is aniline, and if OCH3 or CH3 are present, so what is happening? This can donate the lone pair of electrons towards the ring, thereby making the availability a little better than that of this ammonia. Right. So the electron releasing groups or electron donating groups will make the availability of the electrons on the nitrogen a little more than aniline, thereby making it more basic because of the electron donating capacity of the substituents which are present on the ring. So if there are electron releasing groups like OCH3 and CH3, it will definitely increase the basicity of aniline. And if the electron withdrawing groups, what are the electron withdrawing groups? Like NO2, SO3H, COOH, or X. X is nothing but the halogen here, which can be Cl, Br, or I. So electron what? Withdrawing groups. They will withdraw the electrons from the ring, thereby making the availability of the electrons on the nitrogen still more less when compared to that of the aniline, thereby making it less basic. Therefore, here electron withdrawing groups like all these like NO2, SO3H, COOH, and X will decrease the basicity. So electron, in other words, we can simply sum up that electron releasing groups increase the basic strength, electron withdrawing groups decreases the basic strength of amines or anilines, I'm sorry. This is what substituted anilines. Right. So, yes, when we are trying to explain the basicity of substituted anilines here, right? So here, when it is substituted by OCH3, this is more basic because it's donating the lone pair of electrons into the ring by means of plus M effect. Yes, this is also donating the electrons into the ring by means of plus I effect. So mesomeric effect is more stronger than the inductive effect. So OCH3 substituted aniline is more basic than methyl substituted ones. And when we coming to the chlorine, this is electron withdrawing group by means of what? By means of inductive effect. There is also plus M effect, but here in if there is a chlorine substituted, we know that inductive effect is predominating. So this is what? The electron withdrawing group. These are electron donating group. This is also electron donating group, but this is by mesomeric effect. This is by inductive effect. So mesomeric effect is stronger than the inductive effect here. Here, this is an electron withdrawing group. So this will decrease the basicity. And NO2 is also electron withdrawing group, but by means of minus M effect here. By means of minus M effect. Here minus E and minus M effect here. Right. So this is stronger withdrawing group than chlorine because it's a mesomeric effect and this is an inductive effect. So this is order of the substituted anilines, I mean the basicity order of the substituted anilines here. So it can be explained based on electron withdrawing nature or electron donating nature, and based on the two effects, that is mesomeric effect and the inductive effect. Right, electron donating group will increase the availability of the electrons on the nitrogen. Electron withdrawing group will decrease availability of the electrons on the nitrogen, thereby decreasing the basicity, thereby increasing the basicity. And mesomeric effect is stronger effect than the inductive effect. So I'm writing them in the order of their effects here. Right. So when we are trying to solve this question, whichever is more basic, arrange them in the decreasing order of their basic strength. So decreasing order of their basic strength. So which is more basic among this? See, in my previous video, I've discussed why aliphatic amines. These two are aliphatic amines. And this is ammonia. So aliphatic amines are more basic than amines, ammonia. So amines, right? The aliphatic are more basic than ammonia, and ammonia is more basic than aniline. Just now we have seen, right? This is an aromatic amine. So because there's a conjugation with the ring, they're breaking the availability of the electrons on the nitrogen less here. So in these aliphatic amines, these two are aliphatic amines, then is secondary, one is primary here. So I've already discussed the order of these in my previous video, that my part one. So where secondary amines are more basic than primary. So this is the order. Secondary is more basic than primary amine, which is, yeah, primary amine. Then comes ammonia. Then comes finally this aniline. So this is the aniline. What is aniline here? Yes, C6H5 in H2. This is how the basicity of the amines can be explained, or this is the order of the basicity, decreasing order of the basicity of different amines, aliphatic and aromatic amines. Yes, if you like my video, please do like, share, and subscribe my channel. The whole chapter has been discussed on my YouTube channel, and the details of it, the link has been given in the description below. If you want it, go through the entire chapter, and if you want any video to be made on a particular topic, please share it in the comment section.